Hello children, as you have been experiencing that for this chapter we should know all the formulas of class 11th trigonometric functions. We had already finished up to question number 10 of exercise 2.2. Today we will discuss some more questions of this exercise. Again, we have to find the values of question number 11 to question number 21. So question number 11 is we have to find the value of tan inverse 2 cos 2 sin inverse 1 by 2. Now for this we will assume that let x equals to sin inverse 1 by 2, which means sin x equals to 1 by 2. Now question will be tan inverse 2 cos 2, and in place of sin inverse 1 by 2 we will write x. Now tan inverse 2 will remain as it is. In place of cos 2x we will write the formula because there are three formulas. But since we have assumed that x equals to sin inverse 1 by 2, so we will write the formula of sin x. Cos 2x equals to 1 minus 2 sin square x. So tan inverse 2 as it is, 1 minus 2 sin x is 1 by 2. So sin square x will be 1 by 4. And if we solve it inside the bracket, we will get tan inverse 1. Tan inverse 1 can be written as tan inverse, in place of 1 we can write tan pi by 4. Tan inverse tan pi by 4 is pi by 4. So this is the value of given question. Question number 12. Cot tan inverse A plus cot inverse A. This is 1 mark question. Cot will remain as it is, and you know that tan inverse x plus cot inverse x equals to pi by 2. So cot pi by 2 and cot pi by 2 is cot 90 is 0. So 0 is the value of given question. Question number 13. Now you can see in the bracket sin inverse 2x upon 1 plus x square, which is the formula of 2 tan inverse x. Earlier we have discussed it. Similarly, cos inverse 1 minus y square upon 1 plus y square. This is again the formula of 2 tan inverse y. Now 2 we will take common. So tan 2 into half is 1, and inside the bracket it is tan inverse x plus tan inverse y. Now if we assume this as A and tan inverse y as B, so we will apply the formula tan A plus B, which is equals to tan A. A stands for tan inverse x, plus tan B. B stands for tan inverse Y. So tan A plus tan B upon 1 minus tan A into tan B. So tan of tan inverse x is x plus tan of tan inverse y is y upon 1 minus again x into y. So value of given question is x plus y upon 1 minus xy. In question number 14, we have to find the value of x. We will assume sin inverse 1 by 5 as a and cos inverse x as b. Sin a plus b. So the identity is sin a cos b. Sin a into cos b. So cos of cos inverse x plus cos a into sin b. So cos a, that is sin inverse 1 by 5 into sin b. So sin of cos inverse x equals to 1. Now sin of sin inverse 1 by 5 is 1 upon 5 into cos of cos inverse x is x plus we have to find the value of cos sin inverse 1 by 5 and sin cos inverse x. So first we will find the value of cos of sin inverse 1 by 5, and for this we will assume that sin inverse 1 by 5 equals to theta. So we can write sin theta equals to 1 upon 5. Now we have to find the value of cos, and sin inverse 1 by 5 is theta. Cos theta. So cos theta can be written as under root 1 minus sin square theta, which is equals to 1 minus sin theta is 1 by 5, sin square theta will be 1 upon 25. So cos theta equals to square root of 24 upon 5, and cos theta is cos sin inverse 1 by 5. Similarly, we will find the value of sin cos inverse x. Sin of cos inverse x. Again we will assume that cos inverse x equals to alpha. So cos alpha equals to x. Now we have to find the value of sin alpha because we have taken cos inverse x as alpha. So sin alpha equals to under root 1 minus cos square alpha, which is equals to under root 1 minus cos alpha is x, so under root 1 minus x square. Now if we put the value here, so plus square root of 24 upon 5, and in place of sin cos inverse x, under root 1 minus x square equals to 1. if we multiply both the sides by 5, it will be x plus root 24 under root 1 minus x square equals to 5. We will shift 5 here and this square root this side. So it will be x minus 5 equals to minus root 24 into square root of 1 minus x square. Squaring both the sides, we will get left hand side x square plus 25 minus 10x, and in right hand side 24 into 1 minus x square. After simplifying it, we will get a quadratic equation which is 25x square minus 10x plus 1 equals to 0. After factorizing it by splitting the middle term, we will get 5x minus 1 whole square equals to 0. So 5x minus 1 equals to 0. So x equals to 1 upon 5. In question number 15, you can apply the formula of tan inverse x plus tan inverse y equals to tan inverse x plus y upon 1 minus xy. Now question number 16, we have to find the value of sine inverse sine 2 pi by 3. So sine inverse, as it is, sine, in place of 2 pi by 3 we can write pi minus pi by 3. Sine inverse sine 180 minus theta will be sine theta. So it is sine pi by 3. Now sine inverse and sine eliminate each other. So answer is pi by 3. In question number 21, we have to find the value of tan inverse root 3 minus cot inverse minus root 3. So tan inverse root 3 as it is minus, as we know that cot inverse minus x equals to pi minus cot inverse x. So in place of cot inverse minus root 3, we can write pi minus cot inverse root 3. Now open the bracket, tan inverse root 3 minus pi plus cot inverse root 3. You know that tan inverse theta plus cot inverse theta is pi by 2. So pi by 2 minus pi, which is equals to minus pi by 2. This is the answer of question number 21. Now you should try all the questions of exercise 2.2. Thank you.